Physics Part 101. We got thermal physics and we talk about temperature in the beginning. At the end of 2 sections in this chapter, we should be able to show an appreciation that thermal energy is transferred from a region of higher temperature to a region of lower temperature. We should be able to show an understanding that the regions of equal temperature are in thermal equilibrium. We should be able to show an understanding that there is an absolute scale of temperature which does not depend on the property of any particular substance. The thermodynamic scale and the concept of absolute zero. We should be able to convert the temperatures measured in Kelvin into degrees Celsius. T over K is equal to theta over degree Celsius plus 273.15. We should be able to show an understanding that a physical property which varies with temperature may be used for the measurement of temperature and state examples of such properties. We should be able to sketch the temperature characteristics of a thermistor. We should be able to compare the relative advantages and disadvantages of resistance and thermocouple thermometers as previously calibrated instruments. Our everyday idea of temperature is based on our sense of touch. Putting your hand into a bowl containing ice immediately gives a sense of cold. Putting the other hand into a bowl of warm water gives the sensation of heat. Intuitively, we would say that the water is at a higher temperature than the ice. Think about a thick metal bar with one end at a higher temperature than the other. For example, one end can be heated by pouring hot water over it, and the other end cooled by holding it under a cold water tap. The effect of temperature difference between the ends is thermal energy. The difference between the ends is that the thermal energy is transferred along the bar from the high temperature end to the low temperature. Of course, from the high temperature end to the low temperature end. We can think of this in terms of vibrations of the atoms of the metal. One atom passes on some of its vibrational energy to its neighbors, which originally had less if the bar is removed from the arrangement for keeping the ends at different temperatures. Eventually, the whole of the bar will end up in an equilibrium at the same temperature. When different regions in thermal contact are at the same temperature, they are said to be thermal equilibrium. They are said to be in thermal equilibrium. In physics, we look for ways of defining and measuring quantities. In the case of temperature, we will first look at the ways of measuring this quantity and then think about the definition. Many physical properties change with the temperature. most materials, solids, liquids and gases expand as their temperature is increased. The electrical resistance of a metal wire increases as the temperature of the wire is increased. If two wires of different metals are twisted together at one end and the other ends are connected to the voltmeter, the reading on the voltmeter depends on the temperature of the junction of the wires. On the junction of the wires. All these properties may be made use of in different types of thermometer.